Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
As usual, I'm Teacher Patrick, and this time I will be taking you through Chemistry Senior 1. So if you remember very well, last time we looked at pure substances and mixtures. That was Unit 4. We looked at the pure substances and mixtures. Do you still remember what we talked about? What is a pure substance? What is a pure substance? If you remember very well, we defined what a pure substance means. And we said that a pure substance is the one that contains one component. So the substance that contains one component. And we gave a number of examples, like elements we gave, like gold, like aluminum, and many other examples that we gave. I'm just trying to go through what we talked about last time. You remember what a mixture is? We also defined what a mixture is. What is a mixture? Well, we said that a mixture is a substance that contains more than one component, which is physically combined together and not chemically combined together. So substances that contain components, so the components are physically combined. And these components have to be more than one. So they have to be more than one component. In nature, most of the substances exist as mixtures. Or we said these are also called, the mixtures are also called impure substances. Impure substances. So if we use an analogy of pure substances, then we can also mention mixtures as impure substances. We classified, if you remember very well, did you remember the classification that we made on impure substances or mixtures? Very good. So we said these impure substances are divided into two, if you remember very well. Can you mention one of them or two? Good. So we said that they are either homogeneous, or they are heterogeneous mixtures. So these are some of the, then we gave some other examples. There were some examples that we gave where we said you can have a homogeneous mixture where you have the two components uniformly are mixed together, or there is no any phase distinction. We used some examples. If we can say, even if you have ethanol and you have water, if I remember very well, we also used hydrochloric acid and water. So we said these form one component. So So you cannot distinguish that there are two components when they are mixed together. So they are uniformly distributed. And you remember we also mentioned something like if you have salt and you dissolve it in water, when you dissolve these two, you get what we call a solution. And after dissolving it in water, the salt will uniformly distribute in water and make a solution. So the solution becomes homogeneous. So that is one of the examples. If you remember very well, we also gave some special names that we gave the salt. We said in this case, the salt will be the solute. This is very common, even from the primary. And this water is a solvent. So the solvent plus the solute makes a solution. So that is, we also mentioned something similar to that one. So we're just talking about examples. We also mentioned, we gave some examples of heterogeneous mixtures. These form distinct layers. Well, there are two components. You add the water, you mix them together. Then, for example, you may be having the sand. This is the sand. That is an example. And then you add water. This is the water that I have. So when you add the water, mix them together. I think we did this. And you mix them together, you can easily tell. When you look at it, you'll see the sand goes down. The sand goes down, the water remains on the top of the sand. So they form two distinct phases. There is a solid and the liquid. So this becomes a heterogeneous mixture. So that is one of the examples. Sand and water becomes heterogeneous. This is a solid and a liquid. Or it can be, again, you can have liquid-liquid mixtures. So the liquid-liquid mixtures, we mentioned the oil and water. We gave a number of examples, if you remember very well. So today, we are just going to look at methods of separation of these mixtures, whether homogeneous or heterogeneous. We are just going to look at the methods that can be employed to separate these mixtures. So this is our today's method, our today's lesson. Methods of separating mixtures. So I just wanted to take you through a bit of what we talked about last time so that we can go together even this time around. So there are several methods, a range of them that can be used. You can even mention some of them. For example, if you get beans and you mix them with, for example, with sorghum, that is a very simple example. When they are mixed together, which method do you use to separate them? Very good. So the method is very simple. As you have mentioned, you can use the sorting. When you are sorting, just get the beans, pick one bean, put it aside, get another one, put it aside. That you are sorting. That is one method because that also makes a mixture. If you get the beans, mix them with maybe nuts or beans, mix them with sorghum, as I've mentioned, or mix them with peas, or they are mixed all together. So you just use sorting. Pick one bean, seed, put it aside, a nut, put it aside, and that's what we call sorting. The method, however, I should mention that the method used, or the method that is employed here, depends on the nature of the mixture. I said there are several methods we'll have to look at one by one. So this is one of the methods. This is very common. So there is nothing a lot that we can talk about this one. So I said this one you can use, for example, if you have beans and then you mix them with the G-nuts, and they are even together, so they can be even more than 3, and then you have sorghum. These are mixtures. They are solid mixtures, so to speak. Solid mixtures. So here, I said picking or sorting. We call it sorting by use manually, by use of your hands. That is sorting. We are just going to look at other mixtures. One of them that we looked at where we had oil and water. They are mixed together. You are in the kitchen, you are cooking food, and you have your oil, you want to fry your food, give it more taste, and you need the oil. Oils are very important for our bodies because provide even fats that can even be a source of energy. And you are in the kitchen, all of a sudden, the oil is poured in the water. Of course, you can't be in the kitchen without water. So the oil is poured in the water by accident. What do? So this is what we do in the lab, but I don't think you'll have this in your kitchen. But I'll just talk about what you can do even later on as we continue. So you have, this is oil. We are just going to see, this is oil, this is water, and we are just going to mix them together in this container. This container here is called a separating funnel. Separating funnel. When you hear the name separating, it gives sense. It is a separating funnel. So you have to add, accidentally we said the oil is added. Sorry, it has to be, you have to make sure, every time you are doing this, you have to make sure this tap is closed. And when it is closed, it is horizontal. So you have to make sure the tap is closed so that it doesn't pass through. So you are adding the oil, and at the same time, we are going to add water, so they are going to be mixed together at the same time there. This is water. And this is what happens. So this is the oil, and that is the water, which is, see what is happening here. So something special is happening in this flask, in this funnel. When you look at this, the oil is moving up. You can see the oil is coming here, and when you look here, the oil goes down. Rather, this is the water. Why? Why does that happen? For those who were present in the previous lesson, I hope you still remember. So, this oil, we said these mixtures, both of them, they said they are called immiscible liquids. So the oil is less dense, and the water is more denser. So we are actually, we are using gravity, the principle of gravity. Because the denser one goes down, and the less dense now goes up. So what are we going to do now? It means that if we open our tap here, we will have the water moving down fast. So we are having some water moving down. So what is going down is the water, but you see the oil is still on the top. So we can easily still leave it to settle, and the oil makes a very distinct layer. So we are moving down so that now we have the water which is still moving down. So you have to be very careful as you move towards the end. So you have to open a little bit so that the oil doesn't go down completely. So when you look at this one, you see the oil is still on the top. So we have reduced even the amount of water that was there. So you have to be very careful here so that you don't let so we have remained with the oil on the top. So what has gone down here is the water. Of course, it was also down. So we are using a separating funnel, and who can suggest the method that we are using here to separate this? So we call this one actually decantation. Decantation. It is the method that we can use to separate here immiscible liquids. We had a number of them with the immiscible liquids, so that is one of the methods that can be used to separate oil and water. I said this happens in case the oil is poured accidentally into the water and you are in the kitchen cooking. I believe all of you cook, because all of us cook, because we all eat. So if that happens, I said in the kitchen you don't have this. I think I mentioned it. So if you don't have this in the kitchen, what do you do? Of course, there is nothing that substitutes this, but you can make an improvisation. Now, which improvisation can you make? This is the improvisation that can make. Now, this is the oil. And then you have the water accidentally. Now, this is not accidental because I'm pouring it there now, right now. So this is not an accident. But I'm just showing that if it pours in the water accidentally, what do? You have the oil layer on the top. So what you do, don't immediately separate this, because we have some more bubbles, because this is the emulsion that is forming on the top or in the oil. So you have to leave it to settle, and then the layers form distinctly. The two layers are distinct and you can see them. So what do? This one is just an example that I can use. So if I pour down, I'm pouring the oil, assuming now I'm pouring the oil here. So I can easily get some oil that was poured into the water. I will not use the water. Water with oil, you put it on the fire, please. You'll get burnt. Don't try that one and put water in the oil and then use it for frying. It will burn you seriously. So you have to make sure you separate it in this way. So you have here pure oil. Though I've not completely separated it because I'm using an improvised method, I don't want any water to come into my oil. So that is why I have to make this. And this is the improvisation that can be used in case of decantation. So we are also going to look at other methods of separating the mixtures. In case you have a metal, and this metal attracts the magnet. It is mixed with any other substance. This metal attracts the magnet. So what do? This metal attracts the magnet, and it is mixed with other. So it is in form of powder. So I'm just giving an example. Let me just give an example. This is iron. Iron is strongly diamagnetic. It attracts the magnet very strongly. And this metal, it is in form of powder. So you have to, it is mixed with sand. And then they are mixed together here. So we have the mixture of it mixed together. So when they are mixed together here, this is a mixture. It contains the sand and it is poured here. So the method we use is very simple, as I've mentioned the magnet. So the method that we use is very simple. You use a magnet. And the magnet you are using, the only property that is employed here is that this metal which is here which is mixed with the sand attracts the magnet. And therefore, what we are going to do is to make sure we pass the magnet over the surface of this wood, of the sand, so the iron powder gets out of the sand. So if you keep doing that, then it continues as you get, it is increasing, so you get a lot of it. So you can easily separate it from there. So this is iron powder. It is separated from the sand. So in that case, if you have the metal and then it is, I've just used the sand, let me write it. So here, this is a mixture and you want to separate it. So here we are using the property of magnetization to separate these mixtures. So magnetization is another method that separates the mixtures. Remember, we have looked at the sorting, the decantation, and now the magnetization. Let's look at other method that can be used to separate mixtures. So we'll talk about this method. We have sodium chloride. This sodium chloride is mixed with we have ammonium chloride here. They are mixed together. We are just going to mix them together. This is a mixture of sodium chloride here, and the ammonium chloride. We are going to mix them together. Now, if we mix them together, how do we separate them? So these two substances, this is purely in powder form. This is ammonium chloride. I'm just going to mix it with this is sodium chloride. They are all almost the same color. They are all white. So they are all mixed. And then it is here. So we want to separate this mixture. What do we do? We are just going to boil them, these two mixtures. So you have to take to observe what is happening. So this is a source of heat. So we are heating the mixture of ammonium chloride. We have ammonium chloride. And we have sodium chloride. They are mixtures of two salts. So when we talk about the salts in this case, we are not talking about the table salt. Yes, we have used the table salt, but in general, in chemistry, when we are talking about the salts, we are not referring to the table salt. So we have to keep observing and see what is happening. Takes a bit of, when you look at what is happening, if you can make a very keen look at what is happening there, you will see that there is some fumes of the gas coming up. Maybe we can even trap the fumes. The fumes are coming up, maybe for meantime. We can also even look at some other processes as we keep a keen look at that one. So as we are following even some other processes, this is one other process. I'll come back to this one later on. as we can do even some other method, as we'll talk about that one as it goes on. So it is still going on. Those two components are being heated together, and you see the fumes are almost covering the whole beaker. So that means there is something that is going on. So let's do, you have the water. This is, oh, I've poured some oil in here accidentally. So you have, this is sand. I think if you look at it again, you'll see, I said as you are looking at this one, please, one eye can go the other side and then look at this one as well. So this is the water, or rather this is the sand. So I'm just going to add, this was called water, so it is not hot. So you see what is happening here? These fumes of the gas are coming out. And if we put the cold water, it means the fumes are very hot, so when they come here, they will cool and then solidify on the beaker. So this is the water. I'm just going also to add it in here. I said as we are taking a keen look at this one, we need also to look at this one as well. So accidentally the water is poured in the sand. Maybe the sand was somewhere in a basin or whatever. And then you have very little water to use. What do? You have to improvise. And how do you improvise? In the lab here, we do it differently, but I believe even at home, you'll have to make an improvisation. So this is what we use. So we use this is a filter paper. So folding of the filter paper into 3/4. So you have to fold it this way, like this, into 4/4, and then put it in the filter funnel. This is a filter funnel. And then what you do, then put your mixture of sand. So it will have to go slowly, and then the water goes there. It will be clear. So what I have to come back to this one, when you look at the beaker here, there is some solid forming here. These fumes of the gas here that are coming are, now we said ammonium chloride. Ammonium chloride is a sublimate. So what do I mean by the sublimate? A substance, when it is heated, it changes directly. It doesn't pass through the liquid, but changes directly from solid to gas. And when it cools down, this is what happens. So I have to stop there because this is enough, and it is showing how it goes. So here I'm having another one, which is showing the sand is remaining on the top there. So the solid and gas, this is sublimate. So the method that we are using here is sublimation. So we can have either ammonium chloride, because ammonium chloride is a sublimate. So it has to be a sublimate and another substance which is non-sublimate. So we can have as well other substances. If you have iodine, iodine is another example. Iodine is here, but for this one, probably I will not be able to do it. Next time, we'll start from that one. So, but it is one of the examples of the sublimating substances. So it sublimes, changes from solid to gas directly. And when you come back to this one, this is the water that has gone down. This method, how can you filter this one? This method is called filtration. It is very clear. This is a filter funnel, and this is the filter paper that we are using. And then we collect. The substance which remains on top here, which is sand. So the sand that remains is called the residue. And the water that has gone down here, that one is called the filtrate. So this is what I had for you today. If I wind up, I have to give you an exercise or homework that you can do. So next time when we meet again, then we can answer them together, or you try to answer them yourself. State any 3 methods that can be used to separate mixtures. So, state one principle under which sublimation, filtration is based on. 3, what is sublimation? I wish to wind up from here. I thank you so much for listening, and I hope you've been following. We'll meet again in the next lesson. Thank you so much.